The overall goal of the dissection procedure is to isolate the auditory bulla and capsule, followed by the individual auditory ossicles from postnatal mice for various whole mount and histological analyses.
This method can be used to address key questions in the field of bone biology, such as mechanisms of bone morphogenesis and chondral ossification of bone mineral metabolism. This method is based on in-depth knowledge of anatomical details.
Generally, individuals new to the mouth as a biological system may struggle because their knowledge of human middle ear may not be applicable to the mouth counterpart.
Demonstrating the procedure will be Ayako Sakamoto, a technician in my laboratory.
Begin by placing the auditory bulla and capsule with surrounding skull bone into a specimen dish containing phosphate-buffered saline pH 7.4 at room temperature. Under a binocular dissecting microscope, identify the skull bones surrounding the auditory capsule as shown here. Use one set of forceps to grip the surrounding skull, and a second set to pull away the basis sphenoid and occipital bone. Then, use the forceps to gently pull the intraparietal and parietal bones away from the capsule, and remove when fully loosened. Next, pull the squamosal away from the bulla and capsule, and gently tease away the bone and the soft tissues. Next, grip the outer ear and flip the specimen to reveal the medial side. Next, turn the specimen 180 degrees, grasp the capsule, and pull the remaining soft tissues away. The dorsal crest is now visible. At this angle, the facial and vestibulocochlear nerves in the internal auditory canal, subarcuate fossa, and anterior semicircular canal are clearly visible. When the dorsal crest is angled towards the bottom of the dissection dish, the auditory bulla is clearly seen. If the preparation is angled slightly, then the malleus is visible within the bulla. Begin by using forceps to fracture the external auditory canal above the malleus and lateral to the sulcus tympanicus. Create a second fracture anterior to the first. Then remove the piece of external auditory canal so that the tympanic membrane is visible. Next, remove part of the tympanic membrane and tympanic bone near the malleoprocessus brevis, both at the ventral and posterior walls. The malleus, incus, stapes, and tensor tympani muscle should now be exposed. Lift the malleus and cut the tensor tympani muscle with the beveled edge of a 27-gauge needle. Note that the malleal manubrium firmly attaches to the tympanic membrane, as is seen in other mammals. Dislocate the malleus from the incus at the ossicular joint by fracturing the anterior process of the malleus at the gonial. Isolate the malleus from the auditory bulla using forceps. Remove the major part of the auditory bulla to expose the incus and stapes. Then use the beveled edge of a 27-gauge needle to cut off the posterior ligament of the incus at the short crus. Isolate the incus using forceps. Cut off the stapedial artery near the stapes with the beveled edge of a 27-gauge needle. Rotate the sample so that the round window is positioned at the bottom. Then, insert a sewing needle into the obturator foramen of the stapes and lift up the stapes. After removing the stapes, the oval window opening should be clearly visible. Use the 27-gauge needle to push the stapes off of the sewing needle. To begin tissue embedding, first use scissors to cut off the styloform process at the anterior end of the bulla. The malleus and dorsal crest are visible through the cut portion. Immerse the bulla and capsule in 1 to 2% paraformaldehyde in PBS. If air is trapped in the bulla, remove it using a needle and syringe. Leave the bulla and capsule in the fixative at 4 degrees Celsius overnight on a tube rotator. The next day, wash the bulla and capsule quickly in PBS. Then, immediately immerse in liquid cryo-embedding compound at 4 degrees Celsius. It is common for air bubbles to form in the cryo-embedding compound at the level of the middle and outer ear. Remove the air bubble from the middle ear through aspiration by a needle. Use the same technique for the air bubble in the outer ear. Once all air bubbles have been removed, orient the tissue according to the type of sections to be obtained. The tissue can then be embedded in frozen blocks before sectioning. This image shows H&E staining of a longitudinal paraffin section of decalcified malleus, indicated by the letter M, in the auditory bulla and capsule from a P14 mouse. The tympanic membrane is indicated by the letter TM. This image shows calcium bone labeling of a longitudinal section of frozen undecalcified malleus, indicated by the letter M, in the auditory bulla of a P21 mouse. Calcium green signals reveal new bone formation in the malleus, bulla, and capsule.
Once the technique is mastered, the auditory bulla and capsule can be isolated in 10 minutes if the procedure is performed properly.
After watching this video, you should have a good understanding of anatomical orientations of the auditory ossicles and bulla in the mouth, which are further described in the main text.